Hello, my name is Monika. I'm a user experience and user interface designer at VirtusLab. My work these days is mostly focused on the sizable products with a heavy content. These are huge platforms with thousands of pages and complex information architectures. Along with Tomek, who'll take over the second part of this presentation, we'll tell you a little bit about information architecture in product development. Why is it so important to build a solid IA for your product, and why is it actually so hard to do it? We'll hope this talk is going to be very helpful for you and your teams. I'm going to share my screen now, and hopefully you all can see it clearly. All right, so let's begin and have a quick look at the subjects that we'll be talking about today. During this presentation, we'll try to define what the information architecture really is, why is it important for the users, the people who use our products, and how we can use it as a tool to save time and work effort. We'll then discuss why IA is so rarely seen in product development, why nobody is very eager to map and maintain it, and finally, Tomek will take over and explain the IA seen throughout the dev's glasses, and he'll show you our own attempt to automate the process of mapping. At the very end, we have some time for questions and answers. So first, a quick introduction to information architecture, or IA, as we call it. What is information architecture? There is no single definition, and the concept itself is abstract, but the simplest way to explain it would be to compare it to an architecture of a building. It is a construction similar as the construction of a building that you see on the picture here, but made of information. We have different layers with the building's construction, and one of the first ones, is the backbone of the building. This usually the strongest metal skeleton that holds everything together and upon which all the other layers are being built upon. IS components. Information architecture is present throughout the product development process almost all the time. In many cases, we just don't realize it. We don't know that the things we're working on are pieces of information architecture. So these major pieces of IA are major IA's components. And we have the organization systems, schemes, and structures. Schemes tell us how we categorize information, whether it is alphabetically or by subject or by color or any other. And the structures tell us the information relationships. So they can tell us where the piece of information is located within the whole structure and what is its relationship to other pieces of information environment. We also have labeling systems. They tell us how we represent information by naming, by iconography, by taxonomy in general, but also on-page content organization. So how the information is organized on a single page. We also have two most important, navigation system and searching system. So how we browse or travel through the information and how we search our information. And today we'll mostly focus on the most common components of information architecture, so schemes and structures, organization systems in general. A good IA, once built, is usually very solid and can serve the same product for long years, even if the character of the product itself changes to supply different service. What do I mean by that? Let's imagine I just opened a small business and it's going to be an online shop. And I would like to sell handmade Witcher game figurines, and I need a website for that. But on the other hand, you also need a website because let's say you are an inspiring photographer and you want to have an online gallery and sell your work online as well. So we both need to promote our products, and very likely we can easily find a content management system that will supply us with a website template to do so. It may be very likely the very same template with the same architecture. It can have main page and the navigation to gallery page promoting products, very simple one. And we'll be able to edit most of the visuals of this template. We can change text, content, pictures, colors of layout, the location of buttons, etc. So visuals will change, but the architecture stays mostly the same. And this is why a smartly built IA is a very, very powerful tool for our product to become future-proof. So it can evolve and accommodate changes, whether these are new visual trends or user new needs or business new requirements. I would like to show you as well how often we actually interacting with information architecture throughout the whole product development, not necessarily realizing that what we're working on is actually information architecture. So let's get a next creativity exercise and imagine for a moment that we have a project to deliver and we are not restricted by timelines nor the lack of workforce or funds, and we have the best team ever to work on it. I know, hard to imagine, it happens very rarely, but let's say we have it all, so the process of the product development can actually take place as it should have. And in this way, we have the first phase, the phase of ideation and definition of our product. So what do we want for this product of ours to do, what service to deliver, and what's the big idea for this product? Then we move to the search to figure out whether this idea of ours is valid and can be successful. But at the same time, we also do research within our product. So how it should be built to serve its purpose the best way. And this is the place where information architecture should enter the stage and play the lead role. So we can actually work out one of these solid IAs we talked about a moment ago, because upon this construction, we're going to put the layer of UX and then later UI and all the design throughout later phases. And then we test all this work, and as there are always some bigger and smaller corrections to make, we may end up changing information architecture as well. Finally, we move to development and implementation. Here, the IA gets fragmented and assigned as tasks to deliver for our teammates. So some of them get the search, some get navigation to do, and so on and so on. It is usually also common to double-check and test all the work done again before deployment. Then deployment comes. Once we release the product in deployment phase, there's nothing much to do for IA until post-release improvements are necessary. It often happens as well that after a year or more, a service or whole purpose of the product changes, and then the IA should always be checked and revised whether it can accommodate these new requirements. Now we can move to the importance of information architecture for the end user, and this one's pretty obvious. Of course, IA is a huge part responsible for a pleasant user experience. So people would get frustrated if they enter a house where the windows are installed on the floor, unless this is the purpose, this is how it should be. But otherwise, that's confusing. So IA plays great part in supplying intuitive navigation, stress-free search, and better findability of the content. So the high importance and benefits of well-built IA for the user is hard to deny. But not a lot of people are aware that the IA, especially organization systems, so these graphic forms of IA that we talked about before, these can be very useful for the dev and product teams as well. So let's discuss now possibilities organization systems give the product and dev teams. Above all, it can be a very helpful tool that allows you to see the product as a whole picture. I have had a pleasure some time ago to interview developers and talk about IA in development. And what's very common is that when the IA gets fragmented and everybody gets their place to work on, they work on this piece without the knowledge of how it is connected to the rest of the structure. And you can picture it as the task you give to a group of 3 people. You give them a piece of paper and some colorful pen and ask to draw a piece of a tree. One gets to draw a trunk, other roots, and the last one, the crown of a tree. And each have the very same type of paper, the same coloring set of pens, and the same detailed instructions about how to do it. But once you combine these three pictures, you'll see that the whole picture of a tree is inconsistent because the parts differ more or less, and this is natural. Each person will draw it and will treat this task a little bit differently. So that's natural, but when the tree picture is actually our product, we will often end up with inconsistent user experience and confused users. So IA can avoid that. It can be a gateway to other teammates' work. It can be a source of vital information about the product. And it can also facilitate introduction of new teammates of the product, because you do have this information about the scope of your product, of its structure. It can also be a very powerful visual explanation for either clients, stakeholders, or our own teammates, because it's easier to present the changes you've made when you can actually have a visual picture to compare it, to see how it was before, what was done, and how it looks now when the changes are being made. And finally, this is all very helpful, and we see that IA in product development, when it's done on purpose, when it's planned, it has lots of benefits. But the question is why nobody is very eager to actually do it if it's so helpful? Why nobody is very eager to adapt the IA into their team workflows? Well, at this time, it is quite challenging. It is challenging because IA is hard to build and to maintain. At this time, it is generally a repetitive manual labor. So most IA organization systems are done manually by either information architects or user experience designers. And this requires additional dedicated workforce. It takes lots of time. It is prone to human error because it's done manually, and the structures that are huge and they consist of hundreds of pages, well, it's easy to make mistakes, and you have to also at least try and update it from time to time so the picture is valid. IA maintenance it's hard, it's challenging, but this might be changed by automation of the process. So now I will pass the floor to Tomek, who will show and explain our attempt to automate the IA mapping process. So Tomek, I give you the screen.
Okay, so let's move to IA in front-end development. And we'll start with two definitions of a website. So according to Wikipedia, a website is a collection of web pages and related content that is identified by a common domain name and published on at least one web server. And according to Mozilla, a website is a collection of web pages which are grouped together and usually connected together in various ways, often called a website or a site. So as you can see, both definitions are really similar to each other. But what is a website for an AI-focused developer? So a website is a collection of web pages that is identified by a common domain, yeah? And the second definition would be that a website is a collection of web pages usually connected together in various ways. So as you can see, I've chosen to use only the part domain and not domain name because we will be treating the domain as a problem domain and not as a server domain. Yeah. So in other words, a website is a collection of entities identified by common domain, where each entity has at least one parent entity and is represented as a tree structure. So what's the difference? I will try to highlight the difference on a practical example. And for this practical example, we'll use a simple page, simple car company page, on which, as you can see, we have a menu on the top section with models, home, COVID info, filter on, and similar items. On the body, we have also links to a couple different car models. And on the bottom, we have a footer with features, resources, and about items. And the footer part will be omitted during the analysis just to avoid additional disruption. So let's start with the definitions from Wikipedia. Let's complete the definitions. So we are starting from the root of the problem, the home page. Then we are analyzing all the items in the menu and the items that were included into the body. The structure is, as you can see, really simple on the first level. And the node marked as Google is an external node, and that's why it has different color. The second step would be to search through all these items that we've already found on the root page. The models were already identified. The child elements were identified, so that's why we are skipping it in the step. For the COVID info page, we identified the link to external resource, the Wikipedia. For contact, the same. Okay, so the next step would be to check the connections on each of the children of models. Starting with sports, we can see that sports has two child elements that's marked with the violet arrows, and also all the connections outgoing from sports are marked with the arrows. Sports has direct connections to homepage, to models, and model 2, model 1, model 3, and also to the all items in the menu. The same actions were taken to identify all the connections for SUV element and for the electric cars. As you can see, we have a lot of connections, and that's why for the rest of the child items, I've decided to use one common connection to represent all of them and to simplify the graph. And it looks a bit messy, but probably you already could find that that's a graph representation, and that's a directed graph representation. And now we'll move to an oversimplified tree according to IA focused definition. And as you can see, it looks much simpler. It has only one-way connections, one direction on the connections, and it has no outcoming connections to the root and to the many items. So the side-to-side comparison looks like that. As you can see, the effect on the right side of the screen is much simpler, much less complicated. And from the different perspective, if we rearrange the entities, we can produce a nice tree structure without any duplicates, recurrences, and so on. That was a really short example, so let's talk about the tricky parts on converting one to another, because we converted a graph structure into a tree structure. And two items I've put on the list are how to represent a collection of recurring entities and how to approach menus and other shared sections. So let's continue with the first item. So I've prepared a simple example of a page. The graph here represents the page structure according to the Wikipedia or Mozilla definition. You can see that's a ordered graph structure. We have connections from root to page 1 on level 1, root to page 2 on level 1 also, and from page 2 on level 1 to page 1 on level 2, also between both pages on first level. And all of these pages are pointing back to the root element. So the first step to simplify it to AI definition would be to identify all connections and eliminate all returning to root. So all the connections are listed below. All of the connections are listed below, and we can see that the connections outgoing from page 1 level 1, page 2 level 1, and page 1 level 2, and also from root are going back to root. So we've marked them with orange color. The second step would be to identify all first occurrences of entities. So from the rest of the connections. So we have the first occurrence of the root element, then occurrences for page 1 in connection from root, page 2 also in a connection from root, and page 1 on second level as a first occurrence on the connection from page 2 on level number 1. And with so identified items, we can move to step number 3. So we need to identify first connections to unique entities. Yeah, and as you can see on the left side of the screen, on the top image, I've marked with different colors the entities. I've marked with orange all the arrows going back to the root entity. And after removing the connections going back to the root entity, we have another simplified but still a graph connecting root to page 1 and page 2 from level 1 to page 2 level 2, and page 1 level 1 to page 2 level 1. So now we have to identify all missing connections. So we are still missing the connection from page 1 level 1 to page 2 on level 1. And now we have to transform them to symlinks. So a symlink is a representation of a virtual connection to a virtual node that's pointing to the real child element, page 2, 1. And the outcome of such operations is a tree structure with a home page in the root and separate connections for each item, where each item has only one incoming connection, excepting the, of course, the symlink, which is pointing virtually into the page 2 on level 1. Of course, we have alternatives here. So alternatively, you could use the same trick for the root element as we used for the page 2 on level 1. So you can represent root incoming connection as symlinks. So as you can see, they are marked also in orange, the same as the page 2 level 1 symlink. And on each element, we have a connection going back to the root element. So the second problem was how to approach menus and other short sections. And that's a really similar diagram that I've presented in the first problem. So it looks a bit messy, but in this case, we have a page with 4 related entities, and the menu consists of page 1 level 1, page 2 level 1, and page 3 level 1. And as we can see, all of the entities point directly to these 3 items. So we can define them as a short section. So how to work with such situations? So the first step is to identify all common outgoing connections for all entities. And I've listed them on the right side. So we have connections from root to all pages on the first level, the same for page 1 on first level, page 2, page 3 on first level, and page 1 on second level. And as we identified all the entities that should be included into the short section, we have to identify the first occurrence of the entities. So as you can see on the left, the first occurrence is on the direct connection from root element. Now we can create a virtual container for the short connections. So I've called the container many. The container includes page 1 level 1, page 2 level 1, and page 3 level 1. And instead of drawing direct connections to all of the items, now we can draw connections to the virtual element that you can see on the left side. So instead, for example, page 1 connecting to page 2, page 3, and having connection to itself, we use the virtual container many, draw the connections directly from page 1 to the many container. And because of this operation, we once again converted the graph structure into tree structure. The representation is much simpler than it was before on the image on the left side. So, and now you can see the direct comparison between the diagrams. So, in my opinion, the right side looks much simpler and is much more preferable by developers. And now we can talk about the benefits of using AI in development. So in our internal usage, the AI graphs are an efficient way to communicate between UX and dev teams. Now we can have the common problem understanding. We can represent it in a graphical way. We can also extend the entities with descriptions of all necessary functionalities. So that's a great stuff to communicate with the UX part. Of course, we can also use the trees to create a great documentation for a product, and it's also very helpful to as a documentation for newcomers. So we have lower entry threshold for new engineers joining the product. We can just send them the diagram with some kind of description, and they are satisfied with the effort they need to put into gaining familiarity with the product. Also, another benefit is that's another way to test your application. Because during this presentation, I've shared only a couple tips on how to build the graphical representation, but of course, you can always build such a representation, export it to some format, and run it in some intervals to compare the output to your previous run. That's also that also could be used as a documentation of changes introduced to the application. Yeah, and that's connected to the next point, the great way to visualize development progress to stakeholders. So it's enough to, in many situations, it's enough to prepare a couple of graphs on different development stages and share with stakeholders to present how the progress is going on the development. And another simple way, another great benefit is that it gives us a simple tool to recognize URIs sensitive to the problem of domain subdomain hijacking. I won't go deep into this point, but you definitely remember that in the short past, a couple of really big companies had a problem with domain subdomain hijacking. And as I described in the third point here, using the grasp of the automated solution enables you the possibility to list all of unused subdomains and to secure them. Yeah, there are also many other benefits, but I believe that's out of the scope of this presentation.